Hello everyone, welcome back. In today's lecture, I'm going to start with a new chapter that is about the measurement of screw thread and gear. As you can see in this chapter, we will be covering about the measurement of thread and gears. So we will start off with the introduction portion. Then we will move on with the measurement of external screw thread and internal screw thread. Then what kind of possible errors can be there. Then we will come to the gear portion, and in gear, first of all, we will discuss about the types of gear, then what are the errors in spur gear, then how we will be able to measure the tooth thickness. After that, we will see about the Parkinson's gear testers, then measurement of tooth profile, and measurement of pitch, run out, lead, backlash. These are the terms which are very useful in gear geometry. Then concentricity of teeth. To this we will see in this chapter. So let us start with the first introduction portion. So with introduction, the screw thread geometry has evolved since the early 19th century thanks to importance of threaded fasten in machine assembly, property of interchangeability in association more strongly with screw thread than with any other machine part. Perhaps Whitworth thread system, proposed as early 1840s, was the first documented screw thread profile that came into use. A couple of decades later, Seller's system of screw thread come into use in United States. Both these systems were in practice for a long time and laid the foundation for a more comprehensive, unified screw thread system. Screw thread gauging plays a vital role in industry metrology. In contrast to measuring of geometric features such as length and diameter, screw thread measurement is more complex. We need to measure interrelated geometry aspects such as pitch diameter, lead, helix, and flank angle, among others. The section following introduce screw thread terminology and discuss the measurement of screw thread element and thread gauging, which speeds up the inspection process. We will start off with the screw thread terminology. Now, the first here, this one is the angular pitch. From here, top position to the bottom position, this is the angular pitch. The second one over here is the pitch. Pitch is the six subsequent from one teeth to the another teeth. Third one over here is the major diameter. Here, this one is the major diameter. Then the fourth one here is the pitch diameter, and fifth one is the minor diameter. Up to this, there is a minor diameter, and this one is the major diameter, and here is the pitch diameter. Then the pitch line. Pitch line is shown by this, which shows the pitch diameter. Then apex is the top of the thread is called as apex. 8 number. The bottom part of this is called as root, and the this curved part is called as the crest. Okay. Then addendum and dedendum. Addendum is the top portion, and here above the pitch diameter and below pitch diameter, that is the dedendum up to this root. And depth of thread, this one is the depth of thread, actual thread. Okay. And theta is the angle of thread, and alpha is the flank angle. This one is the flank portion. Okay. So the actual geometry will be of like this. Okay. But we have to keep in mind the major diameter and minor diameter. So major diameter is over here to the curved part. Okay. And minor diameter is over here to the bottom part. because there will be threads on the both of the end. Now the screw thread. The American Society of Tool and Manufacture Engineers ASTME defines a screw thread as a screw thread is a helical ridge produced by forming a continuous helical groove of uniform section on external or internal surface of cylindrical cone. There is one cylindrical cone and external or internal surface helical grooves are found on it, that is called as screw thread. Now the form of thread. This is the shape of contour of one complete thread as seen in an axial section. Some of popular thread are British Standard Whitworth, then American Standard, British Association, Knuckle, Buttress, Unified, Acme. These are the forms of thread. Then external and internal thread. The screw thread on external surface of workpiece, they are called as external threads such as bolt and studs, while the screw threads that are internal surface like in nut. The next portion is the axis of thread, that is the pitch line. This is the imaginary line running longitudinally through the center of the screw, as we have seen the imaginary line running from the center of the screw. In the fundamental triangle, this is one imaginary triangle that is formed when the flanks are extended until they meet each other to form an apex or vertex. That we have seen after the curved portion, the top portion of the curved part is called as the fundamental triangle. Angle of thread. Angle between the flank of thread measured in axial plane. Angle between flank of thread measured in axial plane, that is called as also called as included angle or angle of thread. And flank angle. It is the angle formed between the flank of thread and perpendicular to pitch axis of thread that passes through the vertex of the fundamental triangle. So that is about the flank angle, that is formed from the flank of the thread and perpendicular to the axis of thread that passes through the vertex of fundamental triangle. Then the pitch, it is the distance between two corresponding point on adjacent thread measured parallel to axis of thread. As I explained, lead, very important term. Lead is axial distance moved by the screw when the screw is given one complete revolution about its axis. जब हम एक कंप्लीट रिवॉल्यूशन करेंगे स्क्रू का, तो जब एक्सियल डिस्टेंस स्क्रू मूव करेगा, दैट इज कॉल्ड एज लीड. उसके बाद जो लीड एंगल क्या है, लीड एंगल है दैट इज द एंगल मेड बाय हेलिक्स ऑफ थ्रेड एट पिच लाइन. जो हमारी पिच लाइन है उसके साथ जो हेलिक्स का जो एंगल है विद द प्लेन परपेंडिकुलर टू एक्सिस. जो हमारा प्लेन क्या होगा, वो होगा परपेंडिकुलर टू एक्सिस. और जो हमारा हेलिक्स एंगल बनेगा दैट विल बी द लीड एंगल. देन again here the helix angle made by helix of the thread at pitch line with the axis. यहाँ पे परपेंडिकुलर टू एक्सिस बताया गया है, वो एंगल क्या होगा, लीड एंगल. और विथ along द एक्सिस जो होगा वो हेलिक्स एंगल होगा. इट इज द मेजर्ड एंड एक्सियल प्लेन. Major diameter, as we have seen, the outside diameter, then the minor diameter, the inside diameter. In case of external thread, the major diameter is the diameter of the major cylinder or imaginary, which is coaxial with the screw and touches the crest of the external thread. For internal diameter, it is the diameter of the cylinder and touches the root of the thread. While in external thread, the minor diameter is the diameter of the minor cylinder and which is the coaxial with the screw and touches the root of an external thread. For internal thread, it is the diameter of the cylinder that touches the crest of the thread. It is also called as root diameter. Then comes the addendum and dedendum. It is the radial distance between the major diameter and pitch line for thread. As we have seen, the pitch line and above the major diameter, the radial distance. In other words, the radial distance from the minor diameter and the pitch line of the internal thread, while the radial distance from the major diameter and the pitch line for internal thread. While in dedendum, it is the radial distance between the minor diameter and pitch line for external thread. So both we have seen. Now the effective diameter or pitch diameter. This is the diameter of the pitch cylinder which is coaxial with the axis of screw and intersects the flank of the thread in such a way that it makes width of thread and width of space between them equal. In general, each of the screw thread is specified by the effective diameter as it decides the quality of feed between the screw and nut. So this diameter is the diameter of the pitch cylinder and coaxial with the axis of screw and intersects the flanks of thread in such a way that as it to make the width of the thread and width of the space between them equal. Then single start and multi start. Now the in case of single start, the lead is equal to pitch, which means that the axial distance moved by the screw is equal to the pitch of the thread. Then the multi-start, the lead is the integral multiple of the pitch, and in double start will move by an amount equal to 2 pitch length for one complete revolution of the screw. If we revolve one revolution of the screw, it will move by the 2 times the pitch. Now, next our topic is measurement of external screw thread, and we will see the measurement of internal screw thread. Now, the measurement of external screw thread or screw thread generally elements is necessary not only for manufactured component but also for the threading tools, taps, threaded hubs. Then the section over here is discuss about the measuring the major diameter, minor diameter, effective diameter, pitch, angle, and form of threads. So we will start off with the measurement of major diameter using ordinary micrometer. First device we can use is a micrometer. So for measurement of major diameter of an external thread, a good micrometer is quite suitable. The micrometer is used as a comparator and it is first adjusted on the cylindrical standard of appropriate size having approximately same diameter. The standard is called as setting gauge of size as approximately same as that of the major diameter D of the thread. After taking reading, the micrometer is set on the major diameter of the thread and the reading is taken. The major diameter is given by this equation. D is equal to S plus or minus D1 minus D2. Okay. Sorry. So D is our major diameter. S the size of setting gauge. Then plus or minus D1 minus D2. D1 is the micrometer reading over setting gauge and micrometer reading under the over the thread. First we will check the gauge and we will check the thread. As there is a point of contact between the crest of the thread and measuring anvil, a light pressure must be applied. Do not handle the micrometer ratchet. Otherwise, the error due to deformation of the crest may be introduced. Okay, so that is we have to keep in mind. So next is using bench micrometer. We will see in the next lecture. Up to this, we will keep. Thank you very much for listening carefully. Have a nice day.